with the you do the same thing with the Allen Bradley as you did with the Siemens. So you want to make it go 4 times in one direction, 4 times in the other. And the real reason I want you to do this is because I want you to see the differences between the stepper and the servo, for one thing. And one of the big differences is you don't hear it with the stepper, but you certainly do with the servo. You hear the hum when it's engaged, and when it's running, you hear an actual hum. Okay. And also with the stepper, with the Allen Bradley, you have to configure the extra cards. Now, some of them, the ones that you're going to have, it's not the BB1B, it's the other processors up there, and there's 3 or 4 of them up there, and there's, I think, one in 2330 that I don't know why it ended up in 2330, but it did. But this is the other processor, not the BB1B, it's the other one from Allen Bradley, and I don't know the number on it. It's a 30, I think, it's a 30 something, but it's the other one, okay? So it's the other one, and some of them have cards attached. So what you have to do in order to communicate to this, you have to, when you do your setup, you have to add these cards, which is something you've not had to do before, okay? You have to physically add these cards before you can download to it. And the cards, one is an analog card, and one's a digital card, okay? So you have to look at the card, get the card number, and you have to get it in the right spot. You have to configure it. Now, the adding of those cards is not a big deal, but you have to do it. And you have to answer any questions about it. There's a couple of questions that you have to come up and configure. Anything will work because you're not using them. You're just having to belly up that you've got that card there, okay? So, some of them have these 2 cards, some of them don't. You have to look and see, does mine have the extra cards? If they do, then you have to look at the card names on them and then add them physically, drag them in and add them to your configuration. Does everybody understand that? That's part of this process. And the other part of the process is I give you the base program for it. You can download it. And you have to check to see whether these 2 cards are on that download, and I don't think they are. They may be, but I don't really remember. But then the only 2 differences between the 2 are as you add move instructions, you have to add a tag for each of your move instructions. You have to configure it with a tag. And I just called it like the next one, 05, 06, 07, 08, or whatever. If the word was supposed to be a tag, I'd say tag 05. The next one would be tag 06, tag 07, tag 08, and tag 09, or whatever. You just keep rolling to the next one. Those all have to be unique. Okay? And I think the difference between Allen Bradley and Siemens, another one, is there is a move relative and a move absolute with Siemens. And with Allen Bradley, they're just a move. And there's either a 1 or a 2 that determines whether it's a relative or an absolute move. And I think absolute is 1. I'm not sure, but you have to read up on which one is which. So you have to feed a 1 or a 2 into the type of move that it is. It's on the left-hand side. You have to physically do that. Now let's go back and let's look at the actual, in the chapter 17, and let's review that and see what they say, what I've got in there. But those are the only differences in my memory as to what you'd have to do. Then the rest of it just copy from the other over and basically use the logic of the other one to basically do this one. Okay, so it's chapter 17. I want you to hear the hum. Honest to goodness, in my mind, that's what I didn't hear the day that the thing crashed. And if you get the idea that this is near and dear to my heart, it is, because I should have known to keep the enable. It's either the enable, you hear the hum, or you hear the break. And I had neither. And that's what crash. So that's my story, and I'm sticking to it. But that's what I had. That's what happened to me. I want you to hear that hum, and they all have it. If you're doing a they all set up a big old humming sound. Okay. So this is the and by the way, that's a bigger version of the same stepper that you're looking at, and there's the magnets in there in the armature, and the field is what is modulated. In other words, the armature is fixed with magnets, and the field is changeable based on the electronics. So you have a field out here that is attracted either to a positive or whatever, and basically, it'll make this thing turn or not turn, and it'll hold torque at zero speed. In other words, you can hold something defying gravity with these things, and that's something you can't do with a AC motor. So that's one of the reasons people use these, is because you can hold torque at zero gravity, or zero, not zero gravity, but zero speed. You can hold your part defying gravity with this thing, as opposed to an AC motor, which can't do that. When you get to zero speed with an AC motor, you clamp on the brake and it holds it, and that's the only way they can do that. Here, you don't have to worry about the brake. Although if you lose the enable, you snap on the brake, because you don't want, because when you lose the enable, this thing loses torque. So the enable is what's causing the hum. More than anything else, I want you to hear this stupid hum. So this is the one this is the and this is what it looks like. This is the PLC, this is the power supply, and then these are the extra cards, if there are extra cards. It's an L30 processor. Okay. And you have to change the IP address. You have to address it as, I think, whatever the IP address is set up here. But you actually set up the IP address of the servo as well as the IP address of this, and they have to be able to talk to each other. And I forget what the IP address is set to. I think it's 09, but I'm not sure. To look and see. Okay, so this is the start. This is about 8 to 10-year-old architecture. We bought these originally about 8 to 10 years ago. And then we bought some more about 3 or 4 years ago. So we had 4 or 5 servos, and now we've got about 10. I think we got a bunch, but we don't have very many of these L30 processors. But this is the processor. This is the one you want. Okay, so you can get the IP address from the drives display by using the up and down keys and reading the address one sub-octet at a time. And it should be set to 192.168.0, and I'm not sure what we set them at, but it should be set in here. And this is already done. This part of it's already done for you. The configuration has already been done for you. So you don't have to do this part. You download the program with this already there. This is something that you would have to do if you did it from scratch. And we get down here. Like I said, the part that I want you to hear is I want you to hear it. And the pulses per revolution should be listed in someplace. That's a configured aspect. And I think that should be able to see it. I think it's in one, the number per is 1 degree. So if you say 360, it'll go 1 revolution. I'm not sure, but I think that's what it is. They should already be set up, tuned, and all that good stuff. Oh, we had fun with these. But they've fallen out of use over the last few years because people just didn't have enough time to do this and other stuff. But it is a good lab. Hopefully you will get it done. I think you will. It doesn't take that long. All this is set up. This part of it is given. And there's a lot here. What you should be impressed with is the fact that there are a lot of parameters to be set up. And what you want to do is you want to get a system that most of the stuff is already done, and you can at least very quickly turn the motor, get it to turn. And once you get it to turn, once you get it to at least to that point under program control, then you do the rest of it. But to get it to turn, to get it to actually engage the first time, you can spend weeks doing this stuff. This is not trivial. All these variables, I mean, they just, if one variable is bad or something is off, it can cause it to not work, period. Just one variable out of all this mess. Anyway, I don't want to bore you, but I do want you to understand that, and again, you could build a CAM table, but by making it so that you have this stop or pause and restart, that blows that. You can't do that. And it was the same with both. Both Allen Bradley and Siemens had a table that you could actually set up, but if you had a pause and a restart, that goes away. So you have to build a program from scratch, which is what I wanted you to have to do. I didn't want you to just walk in and build a table and, done. So I didn't want you to do that. I want you to have to, okay, so here are here's what you're given. So there's you toggle that bit and that resets it. You turn it on, you turn it off, you've reset your bit. You turn this one on. First of all, these are like the little toggle switches that you do with the other one, but you don't have toggle switches with the Allen Bradley, so you have to physically toggle these bits. So you toggle this bit on, then you toggle this bit on and off, and then you start playing with these guys. So you can jog here, you can jog it, and then this would be a motion axis move and move type. And this one is, I think, I think 1 is absolute and 2 is relative. I think that, but I'm not sure. And then this one does what? This would be a time delay after the 1. Oh, and by the way, done does not mean you're done. PC means you're done. Phase complete or whatever this is the one that says that you're done, okay? So this would be one, this would be another one. So if you're testing to see if the motion is done, don't use the done bit, use the PC bit. Okay, for this one. Any questions about that? Little trivial things, but not. Anyway, so that's there's your sample program. But all I'm asking you to do is to move that over and do with the, you know what I'm saying? And also build a little HMI screen that does the jog and that type of stuff. Okay. Anybody have any questions how that's done? You about got it done already, right? Any questions? If you need help, let me know. I honestly have fun doing these, so if you get questions or you get into stuck or whatever, I'll help you. Yes, sir.
Generally the move bits, how they work is it's the most, which one is active when you toggle a move bit? So would you have to toggle?
Okay, in order to make, let's go back to this logic. Okay, in order to make.
The reason I ask is because I'm wondering if I'm doing something wrong when it comes to leaving one of the move bits on. Are you supposed to, or are you just supposed to toggle each one?
Well, these are set up so that they need a pulse.
Right.
So you turn this bit on, and then this one scan later blocks it. So this only happens on the leading edge of this. So you have to then turn this bit off, and the next time you want this to happen, you have to turn that bit back on.
The reason why I ask is because our robotics project, it asked us to switch to a move bit from one area to another and then back to the original operating. Whenever we latch a circuit on a move bit, it tends to keep that bit on, but when you flash another bit, it flashes the other bit, and I think it goes back to that one that's on it.
That's Siemens, or it's Allen Bradley.
Siemens.
Yours is different.
Theirs is different. Okay.
This one is looking for a one-shot leading edge.
Okay.
So turn this bit on, this one turns on, doesn't move. Then when the PC bit is done, there's a time delay, and then when it's done, then it does another action. This does this action. A delay after this one. Okay? This is going to be, it's a non-trivial problem. This is a non-trivial project. I say it's just like the other one. It's not exactly like the other one. It's just a little different, but it'll give you a little bit of time to think about it and try to get it to work. Okay, so you got this plus the test, and you've got this week, you got next week, and you know, if you don't get the test back to me before finals week, so be it. And if you don't get this done before finals week, so be it. I'll take them. The last that I'll take anything is Wednesday of finals week. So you've got a little bit of time. I'll show up here during lecture, and I'll also be around and be available for working on this. And I'll be here with my code book if you want to, if the problem is with the code book, there's one or two that need a code book. So I'll have my code books here. If you find a code book someplace else or you Google it or whatever, there's numbers out of a table in one or two cases that you need to look up, and that's it. It's not a big deal. I want you to be comfortable in doing this stuff, but this is not trivial. This lab here is a non-trivial lab. Not many people, not everybody gets it, but most of you will. I think you'll all get it. If you work at it, I can help you as well. Okay? Listen for the hum. And also the shaft. The shaft is real stiffened by the time you hear that hum. It will not turn. So you got it. You got it going, and then that's the enable. That's the enable bit. And then after you got it humming, then try to make it move. And then once you can make it move, see if you can make it move so far, and then see how far you've made it move, and put a little piece of tape on it, and you're all set. Any questions? Any comments? I'll help you. I promise I will not leave you high and dry on this. Okay? And on the test, if you have questions, after you've had a chance to work on it, I'll give you my thoughts on those questions and, even probably tell you where to look in the book. But it's not, these are all right out of the book, except for the number 9, which is kind of, it's out of the videos from Big Bad Tech. He shows you all the parts and pieces, but I'm just asking you to put 2 of them together. But you can do that. You should be able to do that. After you've done all this other stuff, you'll be able to do that. Any questions anybody's got? Yeah. Yeah. Yep, and you're going to be using View and you're going to be using Logix, both, because you need a little HMI screen. Okay? So everybody, as of right now, has credit for the Siemens. You do not have to hand me in a report on it. On the other hand, for the Allen Bradley, I do want to see something. I want to see a report or something that you actually did it and you're involved with it, okay? Any questions? I'm going to shut us down and I'll see you. Have a good day.